Hi, I'm Bobby Balicki from the National Electrical Manufacturers Association, better known as NEMA. Thanks to the U.S. Department of Energy, we are proud to present Vids for Grids, new media for the energy workforce. In partnership with George Mason University, Northern Virginia Community College, and NEMA members, we've developed a series of short educational videos introducing electrical equipment that's used in the smart grid, the electrical grid for the 21st century. This series is going to present a dozen of the most important products that are critical to a smart grid success. Our mission is simple: to make you more aware of smart grid technologies and help you consider a career in power engineering. This edition of Vids for Grids takes us to Melville, New York, where we will visit Leviton, who manufactures lighting controls, a vital part of the smart grid. Here we are in a winter wonderland, which is Long Island, home of Leviton's national headquarters. Today we're going to learn about lighting systems and how they affect the smart grid. So let's go learn something.
The smart grid relates to the production, the distribution, and the local management of energy throughout the United States. It's very exciting to me because a lot of the futures of lighting controls are in the controls area. The lumen outputs, be it incandescent, the traditional lighting source, in residential CFL, increasingly LED technology in both commercial and industrial and residential applications. All of these things need new control paradigms and operating structures in terms of the actual control devices. Leviton plays a variety of roles in what can be defined as the smart grid communications and energy management. It is much easier to manage the existing resources, be they traditional fossil fuels, nuclear, green renewable sources such as wind or solar, and distribute them to the local area. Leviton plays a role in the communications and data networks with our Datacom or Network Solutions division in some of those communications in wide area and local area networks. But of course, we are most known for our lighting controls, and the communications that they have are both at a sensor level and an actuator level. In short, infrared systems can detect body heat and judge occupancy or vacancy in the sector. So one of the first things we saw change in the lighting industry is that these passive infrared sensors were being wedded to lighting controls in the traditional space and used to control relays, be it individual lights or banks of lights. These products, due to the efforts of NEMA and other trade organizations, are increasingly not only encouraged in commercial buildings and have excellent payback financially of under 2 years or less in many cases, but also create green-collar jobs here in the United States. These are installations and design work and projects that are designed, manufactured, and sold in the United States. Many of these products are designed and actually produced in North America for government and military applications that specify domestic or North American manufacture on the devices.
Leviton products are very important in the energy efficiency part of lighting control because that's really the fastest growing part of lighting control. Lighting control systems have changed drastically over the last several years. Where it used to be more just about controlling a small space within a facility, things have changed to where now you're controlling all the lighting in an entire building or an entire facility, maybe even an entire campus. So no longer is it just an isolated conference room with some dimmers in it. It's an entire building or campus that's networked together for optimal control, energy savings, and usage requirements. So now we're not just controlling the lights, but we need to be able to monitor the energy that's being used and also report it to a remote system. So now we can measure that energy usage and report back to maybe a building automation system or some other device that's also on that smart grid and take action. It could be automated action that basically says in high peak periods of energy usage, we want to automatically start shedding loads. So we're going to preset our controls to say when the grid is telling us that usage is getting high, we want to automatically be able to reduce load by shedding unnecessary lighting, maybe even turning that into HVAC controls and signaling those devices as well. The type of customers we target are specifying engineers and more now architects, lighting designers who are working directly with the client to develop a building and develop a plan for using their building or their space in a building. And our job is to work with that design team to develop the optimal control system that can be used to meet the needs of the client and their usage needs, while also meeting the needs or requirements of local and national energy codes, which are driving automation of energy to automatically shut off lights when they're no longer needed. And that's really the bottom line.
So generally, when we are designing the lighting control product, we have to interact with our customers, because they are the one who's actually using the product. So we get some good feedback from the customers, what type of a requirement of the product is, what new product they want to see. So based on those all input, we put together the concept of the products, what high level functionality of the products, and then we involve with the more hardware electronics design and writing the codes for the products and testings and all of those things. So that goes from the alpha prototype to the beta prototypes, and it goes to the final products. The coolest part of being a Leviton engineer is you have an opportunity to work with some of the more advanced technology like wireless lighting control systems, internet protocols, and interfacing with Wi-Fi and all of those technology, which is very exciting for any new college graduate student. So you have a good opportunity, right place, right timing.
Well, I think our industry is expanding into more technical-based products that deliver more value to the user community. And I think that whether it's in engineering or even in sales engineers, to be able to explain and subsequently sell those products, you need to be able to articulate the benefits without being too technical to the users, but understand the technical aspects of the product. One of the things that we've done over the last couple of years is we've split our sales group up into specialized areas, and we employ a fair amount of engineers in the selling effort, as well as the ones that we certainly employ here in our headquarters or at our U.S. plants. So I think that the world we live in is getting into more sophisticated products that do more, but also have a much more technology-based infrastructure.
Young engineering students should experiment and continue to experiment throughout their entire careers, because you never know where it's going to take you. Take the advantage of the time to learn about all the different fields, experiment with them. There's such a broad array of engineering careers out there and engineering disciplines, and it's all about experimenting to find the one that works for you, that feeds on your passions and your interests. And the Smart Grid brings a wonderful opportunity for all of the engineering disciplines, from materials to electrical to mechanical and chemical, because producing materials that will handle power and dispersal of power efficiently, and then also the software to be able to manage that power, brings all those disciplines together.
Today we learned about advanced lighting systems, how they affect the smart grid, and how they're going to put money back into your pocket. From Melville, New York, home of Leviton, on behalf of NEMA, I'm Bobby Bulicki. Mark 5, 23. Action!